In this video, we're going to look at elements, compounds and mixtures. Some definitions to start us. An element contains only one type of atom, where a compound contains two or more elements chemically combined. A mixture is two or more substances that are mixed together, and they can often be easily separated. Elements and compounds are both pure substances. They will melt and boil at a very specific temperature. A mixture, on the other hand, will melt and boil over a range of temperatures. Now we're going to look at separating mixtures. There are 5 main methods we can do. Simple distillation separates a mixture of two liquids that have different boiling temperatures. Fractional distillation separates a mixture of many liquids that all have different boiling temperatures. Filtration separates a mixture of a solid and a liquid. Crystallization separates a mixture of a dissolved substance, such as a salt, and water. And chromatography separates a mixture of many dissolved substances, such as inks. Chromatography is what we're going to focus on today. This is how we set up our chromatography. We have a beaker with some solvent in the bottom. We have a chromatography paper, and we have a lid on the beaker. The lid is added to prevent the solvent from evaporating. The pencil line is where we mark our sample. The pencil line is drawn in pencil because it is insoluble. That means it will not dissolve and move up the paper with the sample. The solvent level must be below the pencil line. Otherwise, the samples of ink on the pencil line will just dissolve into the solvent. You won't get any spots forming. Once we've set up this apparatus and we've added our spot of sample, we leave it to run. The solvent runs up the paper and carries the samples with it. We can see in this example we've got 3 spots. The number of spots is equal to the number of substances in the sample. The distance travelled by each spot is specific to that substance that is inside the sample. And we can use RF values to compare substances in samples. Here I've got a chromatogram where I have pure substance A, pure substance B, and a mixture X. We can tell from X that it contains 2 substances. This is because it has 2 spots. We can measure RF values of these spots, and that tells us how we can compare them to each other. The RF value, called the retention factor, but you don't need to know that, is the distance travelled by the spot, or the sample, divided by the distance travelled by the solvent. If we look at our chromatogram here, we can see for sample B, I've measured this out already for you. In an exam situation, you would just use your ruler to measure it. It has travelled 4.7 centimetres. The solvent has travelled 6.2 centimetres. So the calculation that we do is 4.7 divided by 6.2, and we find the RF value is equal to 0.76. A point to note about this, it's always less than 1. Also, remember, the question will often ask to give your answer in a particular form or to a particular number of decimal places. Make sure you read the question and provide the answer required.